this is a dogfish. Dogfish. Let's see what we have here. Dogfish, you know it is a dogfish because it has two pectoral fins, which are right here. You can see these two fins here are all the way out. You can see that they have feathering on the ends. The dogfish also has a very pointed snout. I have to admit all, because these are the late children all the time. It has a very pointed snout, is another indication that this is a dogfish. It has two dorsal fins, 1 and 2, and 1 caudal fin, which is this one right here. This is the top fin right here. You can see it right there. The shark's head is pointed and its body is long and torpedo-like, giving it a hydrodynamic quality. They have large eyes right here. You can see their eyes are rather on the large side. And then right behind their eyes, right here, is a sensor that helps it to breathe. It helps in its respiration. It has counter shading. So you just want to admit her right there. I don't have a touch screen. It has counter shading. So you'll notice on the top here, it's way darker on the top than it is on the bottom. Okay, the bottom is a lot lighter. This is called counter shading. All right. I picked this out of the bucket that it's sitting on right here, but this is a female. I know it is a female for 2 reasons. It's a female because it has this area right here. And I know it's also a female because its pup is about to be born. So we're going to get to see pups on the inside. They become mature at about 20 years, and they can have up to 6 to 7 babies. So the reason why we are doing this dissection is so that we can learn about the parts and the anatomy of the shark, and we can better understand the anatomy of humans. So here we have, again, the eyes. The shark's eyes are here. If we get a chance, we'll definitely dissect those, but I squeezed it and you can see the iris is opening like that. See it? Right here, down here, are the sensors on the nose. You can tell that they are right underneath the nostril area. This is where these sensors help it to detect its prey in the water. I'm going to have Mr. Staros feel the shark itself because you can actually feel its skin is very sandpaper-like, and it's sticking to the paper underneath.
But only one direction.
Right. If you go this way, it's smooth, but if you go this way, it catches. And the reason why we are going to flip this way and lay it on the plastic is because that way it doesn't catch onto the paper underneath. All right, so let's see, we have,
Good work and play.
Okay, so we can see they have notched the bottom so you can see the bone of the shark right there. It's not really bone. This part right here is cartilage. It is a soft material. It is the same substance that your nose is made of and your ears. So this piece right here, if we were to use this for food, and there are many countries that do use shark for food, this would be gelatinous when it was cooked and completed. So right here we have the tail end, and it's notched so that you can see, and it also fits into the bucket. But that way you can see that area right there is showing you the cartilage. Let me see what else. Gills. So we know that it is a fish because it has gills right here on the side. You can see the gills of the shark. They are open so that water can flow through and out over the gills, giving the shark oxygen. Okay, so we are going to dissect this shark from the top to the bottom, being very careful as we go through it so that we don't cut any of the parts and we're able to see where we're going. So I'm going to open our kits. I know that you guys are missing out on this. I really wish you were here. I wish that we were together. I wish that I had a classroom full of you calling my name and asking me, Miss Braun, what do I do now? I absolutely miss you guys, but I didn't want you to not be able to see this dissection. So that is why I'm doing it for you. All right, you wanna, no, you're still working.
I really miss you, Miss Brown.
I miss you, Oscar, so much. I miss your smile every day. And your arrivederci every time you left me. All right, so I'm making the first cut here. There's another box here. I'm gonna grab scissors out. And I'm gonna make a cut all the way down the center. And I'm gonna try and make sure that I pull up on the skin so that I don't injure any of the organs underneath, trying to keep it as high up as possible. Ugh. As much as these are fabulous for absorption, they are terrible for sharp dissection. Okay, so let's see. Would you cut a very careful line across there? Let's see if we can't lift up this. You can even do it toward you and away from you the other way. Yeah, that way's fine. All right. It's a good thing I did not eat lunch today. All right, I am trying to be very gentle. I can see that this shark has a little bit of a layer of fat underneath its skin. So it was pretty healthy. As I'm cutting, I am noticing the muscles that are right underneath this cage right here. Now, because Mr. Staros and I are both cutting, I'm going to make sure that we are constantly looking to see where the other person's hands are, because I absolutely do not want to slice open my principal.
Where do you want me to go from now?
And then head, as you do that, I'd be very careful, but lift up and then make another line across here, and then we can open that. So if you're working down there, I can come back down here. Okay, watch your fingers. Okay. All right, let's see what I have up here. All right. So the structure up here that we are showing, I am going to grab a little bit of this and absorb some of the water. All right, so one of the cool things about the shark is that it has a liver just like we do, but its liver is much, much larger than our liver. Okay, so if you look right here, we have the liver. It has 1, 2, 3 lobes, just like the frog. Okay, these lobes are rather large and are used to help the shark digest its food. If we come right over here, I believe this tiny organ right here is the heart. And underneath here, this really long thing here, this is the esophagus, which goes right into the stomach, which goes right into the intestines. So we're going to make sure that we get an opportunity to open that up and see what the shark ate before it was caught. So let's see what we have up here. You doing good? All right, so I am going to dissect and move away our beautiful liver. And I'm going to put it on the side. Thank you, Mr. Staros. Okay. So I have that. I'm trying to take it off so that we can see all the parts. Come on, come on, come on. All right. So here is my liver. Go ahead. And you can see that it is still very much attached. It has 3 lobes. One is very small. I wonder why it's so much smaller than the other two, but the last time we dissected one, it was 3 very large lobes, but this one has 2 large and 1 small lobes of liver. I'm gonna put that off to the side. Let's open the esophagus and see what it ate, because that might be an interesting thing. You never know, sharks digest many different things. I believe this one had a full belly. Let's see. Mr. Staros, do you want to squeeze out the stomach? Sure. Okay, so I'm going to give that to you, and you can squeeze it out on the side there. Can we see that? Oh, he's off to the side here. Let me pull this over, and then you can be there. All right, let's see what we got. Well, some tiny fish guts.
Not a whole lot of anything.
Not a whole lot of anything. It must not have eaten recently before it was caught. But it definitely has some digestive fish. All right, we have the gallbladder. We have the ovaries. These are the ovaries right here. We know that this is a female because I showed you the parts. We also know that this is a female for another reason. This is its uterus. The uterus is where the shark carries its young. This particular species of shark gives birth to live young. So they were in the developmental stage. And I'm going to open this up and we'll see how many pups she had. And each pup is in its own individual sac. So let's see if we can't bring this a little closer. Okay, so Mr. Staros has 1. I'm going to continue to cut all the way down and see if I can't open it up all the way, and then we can see how many were there. All right, so this is 1 sac, 1 egg sac. Staros is going to open that up. And this is the other side. Let's see how many of the sharks were in here. I'm pretty sure when I get home, I'm going to need to shower because I'm going to smell strongly of fish.
Mm-hmm.
And then Mr. Staros is going to get home, and Mrs. Staros is going to wonder where on earth he was because he was supposed to be in school all day, right?
Right.
All right, that's one baby, and you can see that it's still attached to the egg sac. This is the yolk, and this yolk would feed the baby until it was fully grown and ready to be born. I'm thinking that this other one right here might have been developmentally a little bit older because this one looks like it was ready to be born right out of the sac. So I'm going to open this one. There are paper towels right there if you want to. Yeah, another pad there, several. Oh, there were 2 in here. So let's see, we've got this one, which was really tiny. Still full egg sac. You can see all the veins still in it. It's very fatty. And the reason why it's very fatty is because this would be the food that fed the baby shark while it was in the mother's womb. And this is the 3rd one. So we've got 3 baby sharks, unfortunately, that won't be born, but that are cool enough that we're going to preserve them and then hopefully be able to view them at another time. All right, so we have opened up the shark and pulled out its gallbladder. We pulled out its stomach. We have gotten all the way down into here. This is the area, this is the cloaca. We talked about the cloaca when we talked about the frog, how all of the feces and the reproduction happens through the cloaca. That is the opening in most of the species of amphibians and invertebrates that do give birth to usually not live young. I think we might have another. No, that's her uterus. Okay. So this is the cloaca where all of the semen entered and fertilized the eggs. This is also the area where all of the feces and urine does exit out of the shark. You can see along the sides here, this very dark line on both sides. These are the aortic veins. These are the major arteries that bring all of the blood to and from the heart and lungs to be oxygenated and brought to the body. Let's see if we can't take a better look at the structure of the tail. All right, let's see what we have here. It's very, very hard to cut through this tail. It's all muscle. It is 100% muscular. It is so very strong. This is how the shark would propel itself through the water. This is very dense, fibrous material. I'm trying to open it so that I can get it, so that we can see the cartilage. Oh my goodness, if you were doing this, you would all be complaining, Ms. Braun, it's so hard. Okay, so right here, you can see the structure of the tail. You can actually see the individual cartilages. You can see each of these would help it to be very flexible and maneuverable. And the rest of this right here would be the main artery going down all the way to the tail. Unfortunately, I apologize for cutting through it, but there was no way for me to know. And then all of it is surrounded by muscle. And the tail fin, you can actually see, is very, very aerodynamic. It could be used as almost a sail, like for a sailboat. So it would be very aerodynamic and hydrodynamic as well, because gliding through the water is almost the same as gliding through the air. How are we doing on time? Oh, we're doing great. Let's see, what else should we cut open, Mr. Staros? Let's see if we can do the brain. Shall we? Let's bring our shark over. You want to take that, and I will get some more pads down. Okay. I would go from the gills. Maybe open the gills. If you want to lift, and I'll put this down. All right, so let's see what the gill structure looks like. Okay, so this is really interesting. I'm noticing that when we are looking at the gill structure, it almost looks like a fan. Can you see that, guys? I think we need to bring it up closer, I'm sorry. You can see it's almost like a fan. Each one of these gill areas right here would be an area that water would go over that surface and allow oxygen to be transferred into the shark's body. Here, wait. Yeah. I got that side. So maybe we need to just cut all the way around through the side and over the mouth, like right to where that cut is. So yeah, keep going. So for those of you who just joined us and don't know, the other pair of hands that is helping me is Mr. Staros. I coerced him into playing today. It would be it was the first shark dissection for both of us, except Miss Grimm and I did dissect one together because that was a lot of fun. And those of you who are in 7th grade got to see that were after school kids. All right, let's see. Trying to get through the head structure here. All right, that's there. I almost wish I brought my knife. All right, let's take a look while we're doing that right here, because you know what? We always normally dissect the jaw. So let's take a look at our shark's mouth structure. And notice it's rows and rows of teeth. For those of you who did the science structable, you know that the reason that they believe the sharks have lots and lots of teeth is because it is an adaptation that it developed because of its skin. They believe that it was almost like scales that eventually ended up being teeth. All right. Watch your fingers. All right. So we can see right here at the top, these are incredibly sharp, teeny tiny teeth. And you can see the row upon row right here. There's a row here, and then a row here, and then a row here. And these back here are almost not even there. But these are definitely rows and rows of teeth on the top and on the bottom. Can you hear that, guys? I don't know if you can hear it, but I'm scraping the teeth, but I doubt you can hear it because the computer's over there. But yeah, it's really, really interesting to be able to feel the sharpness of the teeth and see them in reality. Let's see, if you can hold that, maybe I can cut the jaw this way, then we can see more of the head. This is very, very, as much as I'm enjoying this, because it's really cool, this would have been very difficult for you guys. There would have been a lot of cutting for you, and I'm glad that I did this first, and then I can help next year, but this is really strong. Like, this shark is incredibly muscular. And if you were going to do this in class, it would require both partners, probably even 3 or 4 of you, to do this together. That are sharper. I'll have to get a scissor sharpener because these haven't been sharpened in a couple of years.
There we go.
Okay, all right, so we've taken the jaw off, and Mr. Staros can show you closer the teeth. If we stop moving, yeah, these are really good docking. You can see the teeth, and if you shift it a little bit, you can see the rows of them right there. All right, so that's the bottom jaw. We have a better view right now of the gills right here that go into the lungs, which are under here. Okay, they're down here. We can take a look at the structure of the eye. I'm gonna try and just sever this head off. Okay, so I'm gonna have Mr. Staros pull the eye out. You can cut it. I'm gonna see if I have sharper scissors or a brand new scalpel.
Parents are watching.
Do you think they care? Here, here's a very sharp brand new scalpel, so better.
Oh my God.
The scissors would be better for the big muscles, but this is definitely good for the. So I know it's rather quiet. Sorry, guys. We're just very intensely concentrating. So Mr. Starro says, taking the eye out of its socket, you can see that it has a film on the top of it, and that film helps to protect the eye itself while it's in the water. And if you squeeze it, you can see that underneath, there we go, the part of it down there is the lens back there. So it's got the covering, and then it's got the lens, and then it has the eye. So it's also attached the very same way in the body as a human eye. It's in its socket, and there are nerves that send information to the brain. Now let's see if we can get to the brain of this shark. You want your scalpel? If I wasn't doing this here, I would have been doing this at home with Lily. She's quite disappointed, actually. She very much wanted to dissect. I told her she'll have to wait till next time. All right, so we have the brain. This animal has a very small brain compared to its body, but that brain is responsible for being able to sense where its food is, to take all the information from all of its body parts. It has a very sensitive system on the outside, its nervous system, and it has a lot of different factors that help it to get the information to the brain, because it is a predator. It can sense movement in the water, it can smell fish, and it can sense heat. So it has a lot of different adaptations that help it to figure out where to find its food, because it is a predator. It does not eat plants. It does not eat, you know, algae. This is an animal that eats only meat. It is a carnivore and a predator, and this is its brain. Now, our brain does not look like this. Our brain is 2 hemispheres. This brain happens to be 2, 4, 5 lobes right here, and they're divided up, and they are receiving a lot of information from all of its different senses. All right, so right here again, nostrils, and that is right underneath the brainstem. Eyes right under the brainstem, and then all of the skin and all of the senses on the skin. There are different sensors all along the body of the skin that help it to find its prey. I am going to open up the video for questions. Does anybody have any questions? Raise your hands and I'll let you unmute yourself. Anybody? Wow, it's like crickets in the classroom again. Anybody see anything that was cool that you found interesting? Raise your hands.
I don't know how to raise my hand. I'm
Oh.
not there.
That's right. But what did you find cool, Miss Graham?
I really liked the different egg sacs. Can we cut into one and look at what's inside of one?
Absolutely. So here we can grab one of the egg sacs. And this is the umbilical cord, which is attaching the shark to the egg sac. We know that this cord gives it all of its nutrients, and it feeds the shark. I'm going to open that up, and you're going to see in here that it's basically just directly ingesting into the body of the baby shark this fatty egg yolk, and this yolk sac literally looks kind of like mashed potatoes, but this is literally just nutrition for the shark. And this is high fat and high nutrients that would have fed the shark and allowed it to grow until its proper size. Anyone else have any questions? Ms. Grimm?
Can you see how many vessels are in the cord?
No, you actually can't see how many vessels are in the cord, but you can, as I'm peeling this back, I can see.
I I'd love to smear that and put it under a microscope just to see what it looks like.
That's true. I would too, but those are packed away and my hands are full of goo. So I might do that tomorrow.
All right, so I was gonna say save one because
I could put it in the refrigerator. We'll figure out a way to preserve it so that we can look at it. Anybody else? You guys are ridiculous. This is the coolest thing we've done, and I'm sorry you're not here. I wish that you were. I wish that we had the opportunity to do this together. I wish that you had gotten your hands filthy dirty. I wish you could smell this room. Doesn't it smell fishy? It is very fishy smelling. So
what
those
was
of
Mr.
you-
Star's favorite part?
What was your favorite part?
The eyeball.
Actually, let's cut it open.
Why don't you dissect the eyeball further, Mr. Staros?
I think we will.
I'm currently answering an email, so my gloves are off.
So I will do the dissection of the eyeball. So I did not study the anatomy of the eyeball as much as I did the other body parts, but let's take a look. Trying to remember my anatomy and biology. Gio got kicked out. Ooh, that was very wet.
Mm-hmm.
I'm trying to open it around very carefully.
There's like a
It should be like jelly in there. Like
It is
should be
like
like a
jelly.
jello.
It's more like liquid than Jello right now, dripping through my fingers. Really yummy.
It might be small so you can't find the jelly.
Right.
as easily.
So right there, you can see that is the, I don't know, the inside of the eye. This must be where all of the sensors, because this is very much attached. And you
the
can,
retina, right?
yeah, the retina on the, yeah, I didn't realize it was like a ball.
Mm-hmm.
And then you have the lens over here, and then back here is the sensors, and all of the information goes directly from here through this this cord end to the brain. So yeah, there is your eyeball.
That is cool.
It is cool, isn't it, Oscar? Anybody else have anything they want me to cut open? What else should we
The
cut open?
babies.
What do you want to open, Oscar?
The babies.
The babies? Okay,
Yeah.
I'll do one. Where's the one we took the egg from? All right, let's see what's inside here. So we saw the large version. Let's see what the tiny version is. Mr. Stars, oh no, you have no gloves on. I want to see if the teeth are actually, well, the teeth are not sharp yet, so that's one thing. So this is just like the miniature version of the mom. This is I believe it's a male. No, it's a female. I can tell because it has the two, no, I apologize. It is a male. It has the two parts right there. I'm going to gently cut open. Thank you. I'm going to gently cut open the body. There is a lot of the yolk still in the umbilical cord. All right, let's see what's on the inside of this baby. A lot of the same organs. Here is the tiny liver. Right here is the tiny stomach, and in the stomach is basically the yolk that it's digesting. That is the tiny liver in there. Let's see if we can see any other parts. It might not have been developmentally developed enough to see whether it was female or male. I thought it was a female, and I thought it was male. So there's the inside. Tiny veins. Let's see, going the other way. Little slippery sucker. All right, let's see what we have in here. We can see the basically a very clean shark. You can see the gills are already developed right on the side here. Tiny gills. It has a brain. And let's see, yeah, there's the brain. So yeah, it's all the body parts, but in miniature.